So yeah, here are the tests. It's probably a good idea to know those pretty good, but I do allow you to have a note card with those on it. Kind of have to be a little bit bigger, probably, note card, but use the front and the back. Yeah, put those all down and be able to use those for any series, and that's kind of what I wanted to do is just kind of go through kind of one by one, because some of them I put on there. I'll say I'll use the limit comparison test on this, or use the test for divergence on this test, but there'll be some where you'll have to decide which test goes with which series. So that's kind of what we're going to hit upon today. Those are it, yeah. 10 little tests. All right, so how about we take a look at this one, number 1. Two n factorial over n factorial squared. So if I don't tell you what to use there, what's your thoughts on what you should use there? Well, this is what we got into on Friday, last time. If we have factorials, that's usually, typically, which test? That'd be ratio. Ratio, yeah. Ratio. Ratio test. So maybe I should review that. The ratio test. Okay. So in the ratio test, there's 3 parts. Part number 1, if the limit, and we are absolute valuing all this, as n goes to infinity of a n plus 1 over a sub n, if that's less than 1, then the series is absolutely convergent. Series of the a sub n's is absolutely convergent. If it's greater than 1, that ratio, then it's divergent. And if it's equal to 1, the third thing, then it's inconclusive. Test is. All right, so that's the 3 things on the ratio test. So, what we look at is this ratio here, which this just means the a to n plus 1 just means the n plus 1 term, the term with n replaced by n plus 1. All right, so this is our a sub n. And so I want to look at the limit as n goes to infinity of a sub n plus 1 over a sub n. Okay, well, that is yeah, the bottom term is just a sub n. 2n factorial over n factorial squared. So this top, the top just takes that and plugs in n plus 1. So it'd be 2 times n plus 1 factorial over n factorial, so it'd be n plus 1 factorial squared. Which, one thing we can do to make it a little bit nicer is the absolute value of all all those are positive, aren't they? Since n starts at 1. This would be a positive, that'd be so everything's positive, so the absolute value. What that absolute value usually does is it takes out the alternating series stuff. So anyway, it gets rid of that. The other thing is, we talked about last time, is we're divided by a sub n, but a sub n is usually going to be a fraction. And so it's divided by this. So doesn't that mean times the reciprocal of that? So that would be, let's write it this way. And let's go ahead and distribute. That would be 2n plus 2 factorial over n plus 1 factorial squared. All right, so then, yeah, the bottom is divided. So that means the reciprocal times. So it'll be n factorial squared over 2n factorial. Now, here's why we use this ratio test for that. As we talked about last time, 2n plus 2 factorial. What does n factorial mean? N factorial means, well, let's start with 5. 5 factorial means 5, 4, 3, 2, 1. It's the countdown product, I call it. So n factorial starts at n minus 1, n minus 2. That's the way we could write that. What about 2n plus 2 factorial? Well, which is what we got there. Well, 2n plus 2 factorial, I could write that as sort of like this. The first term is 2n plus 2, right? Then what would be the next term? It'd subtract 1. Yeah, 2n minus 1. And 2n minus 2? 2n plus 1, sorry. Yeah. The next one, 2n. Because I'm just subtracting 1 every time, right? And then so forth. Well, the thing of it is, right here, starting with, isn't that 2n factorial? 2n, then 2n minus 1. That'd be 2n factorial. Okay, so let's write that. 2n plus 2, then we're saying is 2n plus 2, 2n plus 1, times the 2n factorial. And the reason we do that is because, you'll notice, on the bottom over here, I have 2n factorial right there. So those are going to cancel. All right. Now what about this? Well, let's think about that. N plus 1 factorial squared. Is that what I got? That is what I got. Okay. All right. So n plus, well, let's say n plus 1. So n plus 1 factorial, we could do the same way. We could say that's n plus 1 times n factorial. Then I got to square it. Which, squaring that means I square both of these, right? So it'll be n plus 1 squared and n factorial squared. With me? Okay. Well, again, canceling out the n factorial squareds. Leaves me with the limit, as n goes to infinity, of 2n plus 2 times 2n plus 1. That's all that's left on top, right? Just these two. And the bottom is n plus 1 squared. So that's why this ratio test is a good one, because it gets rid of, usually the ratio test gets rid of all the factorial stuff. Now it's just a regular limit. How do I do that limit? Well, let's go ahead and multiply that out. Wouldn't that be the limit as n goes to infinity of 4n squared? See, 2n and 4n be 6n plus 2. N plus 1 squared, n plus 1, n plus 1 would be n squared plus 2n plus 1, which if we divide by n squared, top and bottom, it all works out well. You got the limit as n goes to infinity. 4, 6 over n, 2 over n squared, 1, 2 over n, 1 over n squared. That's 0, that's 0, that's 0, that's 0, so it's 4. 4. Right? So this limit is equal to 4. So what is the ratio test? Where does that fall in? That's number 2, isn't it? We've got greater than 1, that limit. It's greater than 1. So the series is divergent. All right, by the ratio test. So just remember, a factorial, use ratio test. All right. Okay, well, what about series? -1 to the n minus 1 over ln of n to the n. It is an alternating series, but the thing of it is, we didn't have a whole lot where we had, notice here, I've got exponential, but I've also got n in the base. And we talked about one such as this last night too. That's, if you have n in the base and in the power, that's root test. If you've got n in the base and then n to the, if the n was just on the outside as the power, that would be probably geometric. Different things with the inside. But if it's on the inside and the outside, the n, the base, and the power, that's root test. Well, what about the root test? Here it is. Remember, the root test works about the same way as the ratio test. Number 1, if, however, you look at the limit as n goes to infinity of the nth root of a sub n, absolute valued. If that's less than 1, then the series absolutely converges. Number 2, if this limit of the nth root of the absolute value of n is greater than 1, well, guess what? The series diverges. And it's inconclusive if it equals 1. That's the root test in a nutshell. Okay? So how does that work on this one? All right, well, we need to look at this limit. The limit of the nth root, limit as n goes to infinity of the nth root of the absolute value of a sub n. Well, guess what? The absolute value part takes out the alternating part of this, alternating sign part of that. So this would just be, wouldn't it? Everything else is positive, so it would just be the limit as n goes to infinity of the nth root of 1 over ln of n to the n. Wouldn't it? Because the absolute value would take care of this top part. Because that's just the alternating signs, right? Everything would be positive, so there's no alternating. It's just 1 on top now. It's not 1, negative 1. With me? Well, that's good because since I'm doing the nth root, that's where the beauty of the nth root test, the root test comes in. We're doing the nth root. Well, the nth root of 1 is just 1. The nth root of, what's the nth root of ln of n to the nth? Well, the nth root of the ln of the nth root, or the nth power, yeah, the root and the power cancel out. Just ln of n. So, we're in good shape. Now, n goes to infinity. What do you got? 1 over infinity? 0? That's 0. Which is less than 1. So, by the root test, this series, negative 1 to the n minus 1 over ln of n to the n, lots of n's, is absolutely convergent. Yes. Because remember, yeah, put absolutely convergent because remember, absolutely convergent is a little stronger than just convergent. It's absolutely convergent. Okay. So yeah, that one's a little tricky because yeah, you had the alternating series, but really the key part was you have n to the n, and anytime you have n to the n power, look to the root test if you're having to decide which test to use. All right. Okay. So we've got a few more. What about negative 1 to the n minus 1 over 2n minus 1? Well, that being, what do you got there? Yeah, again, we have an alternating series, don't we? Well, if it's an alternating series, let's try the alternating series test. That's probably number one thing to try. If it's an alternating series and it's not an nth power to an nth power, or an nth something to the nth power, yeah, that's going to be your first thing to try would be alternating series test. The AST. For alternating series, makes sense. Okay? All right, so what were there were two things on it, right? Number one thing was, first of all, B sub n. We call B sub n just the part without the alternating signs. So 1 over 2n minus 1. This whole thing would be A sub n, so the B sub n is just the part without the alternating signs. Remember that. So the first part of the alternating series test is comparing the B sub n plus 1 to the B sub n, and it needs to be decreasing, right? So we need less than this. We need the B sub n plus 1, which would be 1 over 2n plus 1 minus 1, which would be 1 over 2n plus 2 minus 1. I think that's going to be an easy comparison, isn't it? Because that's 1 over 2n plus 1 less than 1 over 2n minus 1. Is that a check? That's true, isn't it? How do we know? Well, this is pretty easy. This, compared to that, wouldn't this denominator have to be bigger? Bigger denominator, right? So that, yeah, that's an easy. That's true. Because you have 1 over the bigger denominator compared to 1 over the smaller denominator. Yeah, this is going to be the smaller of the two. So that's checked. What's the other part? Huh? It's got to equal 0. The limit of the b sub n's as n goes to infinity needs to equal 0. So we look at the limit of the b sub n, which is 1 over 2n minus 1. Maybe do a little divide by n action here just to make it all totally clear. That's 1 over n. That's 2 minus 1 over n. That's 0 over 2 minus 0. That's 0. Check. So we've got decreasing terms. We've got limit of the b sub n's is 0. Alternating series test says, yeah, this converges. Alternating series test. Okay?